Okay, today's lecture is Chapter 6, Discrete Probability Distributions. Okay, let's start. Okay, so in this chapter, the main theme of this chapter is random variable. Random variable is a function or rule that assign a numerical value to each outcome in the sample space of the random experiment. We use usually x when we're referring the random variable or y or something like that in general, while the specific value of x are shown in the low case. For example, x1, x2, x3, something like that. So random variable often is direct result of an observational experiment. Okay, so for example, counting the number of takeoffs in airport or something like that. So there is two cases of random variable. One is discrete random variable and continuous random variable. So this chapter we only think about the discrete random variable. Okay, and sometimes this discrete random variable has upper bound, upper limit. For example, number of absence in a class of 40 students, or sometimes it has no upper limit. I'm sorry. So, for example, the number of text message you receive in given hour or something like that. Okay. So here is the example of random variables. So number of admitted MBA students, or number of phone calls, number of defect in 500 meters of the road steel. So their random variables looks like a function, and random variable does not have only one value, but it has many possibilities to have an outcome. So random variable always go together with probability distributions. So the random variable which has no probability distribution is nonsense. So all the random variables has probability. So I mean the distribution is that given by this probability. So you studied the probability at chapter 5. So probability that our random variable x has value x1 is denoted by probability of x1. Okay? Probability that x has value number 2, then that is denoted by probability of x2, something like that. So then the x is x1 or x is x2, or this kind of expression is they are or event. So probability is the map from event to the value between 0 and 1. So we have this notation. Okay. And this probability, so as we studied in chapter 5, the sum of all probabilities should be same as 1. Okay. So actually, more mathematically, the notation x is same as xi is actually, it is the set of some sample space such that x omega is the same as xi, and I is 1 to n. So that is I'm sorry, xi is this set is given by this notation. Okay, so discrete probability distribution is it is the function. So the discrete probability distribution follow the rule of functions. So that means more than one sample space outcome can be assigned to the same number, but you cannot assign one outcome to two different numbers. So here is x and here is outcome. So between some in 0 and 1. So then here is x1, then it can go to some number, for example 1 over 2 or something like that. And x2 can go to 1 over 3 or something like that. Or so x3 is here mapped to this point. But for example, here is x and here is interval 0, 1. Then some x cannot go to assigned two numbers. It is impossible. It is impossible. So that is the first sentence mean. Okay. So that is, yeah. So we apply this rule of function, then we can say like this. Likewise, more than one random variable value can be assigned to the same probability, but one random variable value cannot have two different probabilities. Okay? And it is important that it is not comes from the property of function. So it is only the probability distribution has this rule. So the probabilities must sum to 1. Okay? So that is only original property of the probabilities. For example, so sample space, if you roll a dice, then sample space is 1 eyed, 2 eyes, 3 eyes, and so on. So then random variable x is assigned to the number of eyes. So then here, this one is assigned to the number of eyes 1, number of eyes 2, number of eyes 3, and so on. So then probability distribution is that the probability that one-eyed face will come. So then that is 1/6. Okay, the probability of 2 is 1/6, and so on. Probability of 6 is 1/6. If this dice is equal, then we have this probability. So here is random variable, here is probability. So random variable always go together with probability. Another example is that coin flip. So you flip, so tossing a fair coin. Fair coin means that, so probability of head is 1 over 2, probability of tail is 1 over 2, then we say that it is fair coin. So flip a fair coin 3 times. So then we can imagine the possible outcome: 3 heads, 2 head, tail, tail, head, tail, head, tail, tail, head, tail, head, tail, tail. So that is possible outcome. So that is sample space S. And X is random variable. Random variable is a function from the space to real number. So random variable X is the function from space to real number. It is R is the set of real number, S is our sample space. So sample space is here, sample space. Okay, so then the X is the number of heads. So in this case, number of heads is how much? So we have 3 number of heads. In this case is we have 2 number of heads. In this case is we have 1 number of heads. In this case we have no number of heads. So the possible event is tail, tail, tail. In this case, the random variable is 0. So in this case, head, tail, tail, or tail, head, tail, 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 head. In this case, we have a random variable 1. And in this 3 case, the number of heads is 2. In this case, number of heads is 3. And so the probability that our number of heads is the same as 0 is this case, out of 8. So it is 1 over 8. So this notation, the probability that x is same as 0, this notation is simply probability of 0. And probability that, so the number of heads, x is number of heads is the same as 1, is this 3 case 1, 2, 3 out of 8. So it is 3 over 8. So this probability is simply, we say that this probability is P1. So P1 is 3 over 8. And that is, again, we have 3 number of heads. So it is probability of 2. It has 2 number of heads. So it is probability 2 is 3 over 8. And probability for number of head is 3 is 1/8. So and sum up to 1. Sum of all the probability is 1. So we can draw this diagram. It looks like a histogram, but it is they say that it is probability distribution. It is probability distributions. So the probability of 0 head is 1/8, and probability of 1 head is 3 over 8. Probability of 2 heads is 3 over 8. Probability of 3 heads are 1 over 8. Okay. So it is probability of 0, probability of 1, probability of 2, probability of 3. So expected value is the same as mean or average. Mathematically they are all same, but when we consider the random variable, we say that it is expected value. So we denote the expected value as E of x, EX. So in this case, we have to use the uppercase, so capital X. So the small x are all outcomes. Or, so this mean of x expected value is denoted by x mu, So this symbol is pronounced mu. Okay? So it is Greek letter, so mu. And mu is expected value, and expected value is defined by xi times probability of xi and summation. So all the possible outcome times the probability of this outcome and summate them. So then we say that it is expected value. For example, so the distribution of Sunday emergency service call by a appliance repair shop is shown by this table. So the probability that there is no service call at Sunday is 5%. There is only one service call at Sunday is 10%. 2 service call probability is 30%. 3 service call probability is 25. 4, 25, 10. So then here is xi times probability of xi. So it is x1, x2, and so on, x6. So then xi times probability of I is that. In this case, so x1 is 0, so multiply this value times this value, then it is 0 because it is 0. Okay, so then so the first value is 0. And 1 times probability of 1 is here. 2 times probability of 2 is here. 3 times probability of 3 is here, and so on. So then that is the element of summation. And if we sum this value up, then we have this 2.75. This 2.75 is mean of x. Mean of x is 2.75 because mean of x is summation and is 0 to 5 and as 1 to 6 xi times probability of xi. Okay, so we can check this so definition, then we obtain the mean. Okay, so here is again the mean of service call. X is that 0 times probability of 0, 1 times probability of 1, and so on, and 5 times probability of 5. So we apply these values, then we obtain the 2.75. So here is the possible, so the random variable x is 0, then probability that 0, probability of 0 is here, random variable is 1, then probability of 1 is 10%, random variable 2, random variable has value 2, then probability of 2 is 30%, probability of 3 is 25, probability of 4, probability of 5. So then that is, this graph is the distribution. Yes, so we can also study the variance. We can define the variance of random variable x. So variance of random variable x is usually denoted by sigma square. So this one is sigma, Greek letter sigma. Sigma square, then this notation means that variance of x. Variance of random variable x is summation I is 1 to n xi minus mu. Mu is mean of x square times probability of xi. Okay? So this equation, if we use this equation, then we obtain the variance of x. And the standard deviation is simple. If we take the square root of variance, then that is standard deviation. So then, standard deviation always use the expected value. So without expected value, we cannot calculate variance. Okay, and okay. For example, bed and breakfast. So, the Bay Street Inn is a 7-room bed and breakfast inn. Yeah, in the somewhere, so yeah, Long Island or so California somewhere. Okay, so then the random variable x is the number of rooms rented. X is the number of rooms rented because this inn has 7 rooms. So number of rented rooms can be 0, 1, 2, 3, and it is limited by 7. Okay. So, and let's calculate mean and variance of the number of rooms rented. Here is the probability. So it is given. So you cannot find the probability by yourself. It should be given. the probability that there is no rented room is 5%. The probability that rented room will be 1 is 5%. Probability that number of rented rooms are 2 is 6%, 3, 10%, 4, 13, 5, 20, 6, 15, 7, 26. So this information comes from the the statistical investigation. So you need not to worry about these values. It should be given. Okay. So then mean. To calculate mean, we have to calculate mean is, as you know, mean is expected value is xi times probability of xi. I is 1 to n. So we have to multiply this number and this number, this number and this number, this number and this number, and so on. So that is these values. Okay. So after then we obtain the sum of these numbers, and 4.71. So that is expected value. Okay, now, so here is mean, so expected number of x, expect value of x. Now, so let's calculate variance. To calculate variance, let's see the equation for variance. Equation for variance is here. So you should calculate the xi minus mu square. Mu is expected value. So we need this one, xi minus mu. Xi is 0, 1, 2, 3, 4, 5, something like that. And mu is 4.71. So 0 minus, first value is that 0 minus 4.71. Second is 1 minus 4.71. Third is 2 minus 4.71, and so on. So then here is 7 minus 4.71. So then we obtain these numbers. Okay. And so the variance is given by I is 1 to n, xi minus mu is here, square times probability of xi. So we have to take the square for each values we calculated. So then minus 4.71 square is here, minus 3.71 square is here, and so on. So x minus mu square is given in this column. Okay, and then finally we multiply this value with this value, multiply this value with this value, multiply this value and this value, and so on. That is x minus mu square times probability of x. So this one, that is given in this column. So this number times this probability, and this number times this probability is given in here and here, and so on. All the values are multiplication of this number times this number is here, and so on. So then these numbers are xi minus mu times square times probability of xi. And then we sum them up, then we have this value. This value is variance of x. Variance of x. Okay, so then we have this number, variance of x. This number, mean. And standard deviation is square root variance. So we obtain 2.0557. And that is the distribution. The probability that rented room will be 0. Probability that rented room is number of rented room is 1, probability rented number of rented room is 2, and so on. Okay, so that is distribution. Okay, so this probability distribution, so all the random variables are go together with probability. So so this distribution is can be described by probability distribution function PDF, or cumulative distribution function CDF. PDF and CDF are classify the property of a random variable x. All the random variable x is defined by the probability density function or probability distribution function or cumulative distribution function. Okay, so this kind of figure, this kind of table represents the probability density function. So we saw the probability density function in here, and another probability density function is that. So this one, figure 6.3, is also the probability density function for the service call. And this one is the probability density function for bed and breakfast, random variable. Okay. And cumulative distribution function is the cumulative sum of probabilities. So cumulative distribution function is, cumulative distribution function is probability that x is less than xi. So that means sum of probability of xj, and j is 1 to I. So then if we accumulate the probability of xj until I, then it is cumulative distribution. So here is, if we have the probability density function as this graph, so then cumulative density distribution function is, cumulative distribution function of 0 is this one, and 1 is sum of these two numbers. Cumulative distribution function for 2 is sum of these three numbers. Cumulative distribution function for 3 is sum of these three numbers, and so on. Cumulative distribution for 8 is sum of these numbers, these numbers, so it is tall. And the probability of 14 is sum of all the numbers in the graph, so it is here. And as we studied the probability density function, sum of all the probability density function is always 1. It is always 1. So the cumulative, the last number of cumulative distribution function is always 1. So that is probability density function and cumulative distribution function. Okay, so we will study some distributions because random variable always go together with probability. So the random variable can be classified when all the property of random variable is included in this probability. And this probability is described by probability density function, as we studied. So if we know the graph of this probability function, then so we can calculate mean and variance. So this graph is probability density function. So this random variable can be described by probability, and probability density function is all the probability of random variable x. So study the random variable has the same meaning as study the probability density function. Okay? And probability distribution function is another name of probability distribution function is distribution simply. Okay? So study the distribution means that study the probability distribution function or study the cumulative distribution function. So study the distribution means that study the probability distribution function. And study the probability distribution function is the same meaning as study the random variable. So if you want to know the property of random variable, then you should study the probability distribution function. That means you should study the distribution. Okay. So today, we will study some three distributions. Uniform, Bernoulli, and binomial. And so the first distribution is Poisson, but Poisson distribution is so difficult, so let's skip in this semester. Okay, so then we will study the three distributions. So then we may study the three different random variables. Okay. The first distribution we will study is uniform distribution. Uniform distribution. Uniform distribution is that each value is equally likely. All the values will happen equally likely. In this case, we say that it is uniform distribution. So, uniform distribution has a lower limit and upper limit. Lower limit and upper limit. And uniform distribution, lower limit and upper limit A and B means that random variable x can have a value a or a plus 1 or something like that, and b minus 1 and b. So these numbers are possible outcome of this random variable x. The probability that the random variable x has a value x between b and a and b, between a and b is 1 over b minus a plus 1. That is probability distribution function. Cumulative distribution function is sum of them, so that is the cumulative distribution function. So domain is a1, a2, a plus 1, a plus 2, blah blah blah, and b. So a plus 1, a plus 2, and b minus 1, b. So that is possible outcome. So that is domain of uniform distribution. Mean is a plus b over 2, a plus b over 2. And standard deviation is given by this equation. It is a little difficult to verify, so let's accept this equation. And when you'd like to use the random number generation in Excel, then you can use the random between a and b. So if you use this function, then Excel randomly choose the number between a and b and give the answer. Okay. So for example, if you roll one die, then that is very good example of uniform distribution. So we have 6 possible outcome, 1, 2, 3, 4, 5, 6. And all of this possible outcome probability of x is 1, number of i's. Probability that x, number of i's, is 2, is all the same. Probability of x is 6, and that is 1 over 6. So all possible outcome has the same probability, then we say that it is uniform distribution. So mean of this x number of i's when you roll one dice is 1 over, so it is mean of x is 3.5. Okay. So it comes from the fact that I is 1 to 6, I times probability of I, so that is sum of I is 1 to 6, I times 1 over 6, so that is 1 over 6, sum of I is 1 to 6 I. So you just sum up 1 plus 2 plus 3 plus and 6 and divide by 6. So 1 plus 2 plus blah 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 6. So then you obtain 3.5. So mean is 3.5. Okay. So it is probability distribution function, PDF. It is not out of PDF. Okay. It is probability distribution function. And this graph is a cumulative distribution function graph. The first one is this one, and second one is sum of these two. Third one is sum of these three, and so on. 6 is sum of them all up. So it is exactly same as 1. Okay. So mean is 3.5, and the standard deviation is square root b minus a plus 1 square minus 1 over 12. So we obtained the 1.708 as the standard deviation. Random number generation is very important when you do the Monte Carlo simulation, but in this course, we will skip it. We will better skip it. Okay. That is uniform distribution. Okay, this simple distribution. So all the possible, so all the outcome has the same probability to happen. Then we can use the uniform distribution. Another very simple distribution is the Bernoulli distribution. So Bernoulli is the name of a mathematician. Okay. Bernoulli distribution has two outcomes: success, failure. If something outcome is success, then we denote that x is 1. If something is failure, then we denote that x is 0. I'm sorry. So the probability of success is denoted by pi. So it is different from the pi of 3.14. So it is not this value. Pi is just one notation. The probability of failure, probability of success is pi, then probability of failure is 1 minus pi, because if we sum this probability of success plus probability of failure should be 1. So if the probability of success is pi, then probability of failure is 1 minus pi. Okay. So the example of Bernoulli distribution is that flip coin. 1 is head, 0 is tails. And jet turbine blade. So 1 is crack found, 0 is no crack found. So the probability of crack found is 0.1%. And the purchase tank of gas, 1 is paid by the credit card, 0 is do not pay by the credit card. So in this case, the probability is 0.78, and so on. Okay, so that is simple Bernoulli distributions. So mean and variance of the Bernoulli distribution is very simple. Mean is pi and variance is pi times 1 minus pi, because the mean is sum of xi times probability of xi. So xi has two possible values, 0 and 1. So here is 0 and 1. The probability that we have 0 is 1 minus pi. 0 means the failure, and 1 means success. And probability of success is pi. So 0 times 1 minus pi is 0. So that is 0. And 1 times pi is pi. So we have pi. That's Bernoulli mean. And variance is xi minus mean of x squared times probability of xi. So here xi can have 0 or 1. It is failure. I'm sorry. So failure and success. So then, I'm sorry, this failure and success. Here is success, this success, this failure. So then 0 minus mean, it is mean of x, expected value of x, that is expected value of x, and square, take the square, and times the probability of failure. Probability of failure is 1 minus pi. Probability of success is pi. So after we calculate this equation, then we obtain that pi, 1 minus pi. Pi times 1 minus pi. That is the variance of Bernoulli distribution. Okay, so it is the second distribution we will study. And the third is the binomial distribution. It is very important distribution, so I hope you can study this binomial distribution. Binomial distribution is made by the Bernoulli distribution. I mean, binomial random variable x, x is the binomial random variable. Binomial random variable is sum of Bernoulli random variables. So x1 is Bernoulli, xn is Bernoulli. So they are all the same, n independent Bernoulli random variables. Sum of n independent Bernoulli random variables are generate binomial distribution. So mean of binomial distribution is sum of mean of Bernoulli distribution. So and Bernoulli distribution, x1 is the mean, the expected value of Bernoulli distribution, ex2 is expected value of Bernoulli distribution, exn is the expected value of Bernoulli distribution. And Bernoulli distribution has the expected value pi. Bernoulli distribution has expected value pi and pi. So we have pi n times. So we have n pi for the binomial distribution. Binomial distribution has mean n pi because binomial distribution is defined by the sum of Bernoulli random variables. Standard deviation is that so square root n pi times 1 minus pi, because the variance, so this independent is very important, but we will study the independent later. So n Bernoulli trials are independent, so variance of a binomial distribution x is variance of x1 plus variance of x2 plus variance of xn. And x1, x2, and xn are all the Bernoulli random variables. So Bernoulli random variables, variance of Bernoulli random variable is pi times 1 minus pi plus, here is also pi times 1 minus pi plus pi times 1 minus pi. So finally we obtain that n times pi times 1 minus pi is the variance of x. Okay? So we have n times pi 1 minus pi. So that is variance. So to obtain the standard deviation, we just take the square root for the variance value. Then we obtain the standard deviation of binomial distribution. Okay. So that is binomial distributions. So please keep in mind the mean of binomial distribution is sum of Bernoulli random variables. Binomial distribution is obtained by the sum of Bernoulli random variables. And mean is n pi, and standard deviation is square root n pi times n minus pi. Okay. So then let's check the probability that binomial distribution has value x. So then it is probability that x has the value x, small x, is given by this equation. So that is probability density function, probability distribution function of binomial random variable. Okay. So this one, x factorial, means that x times x minus 1 times blah 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 and 1. So n factorial means that n times n minus 1 times and so on and 1. For example, so 3 factorial means that 3 times 2 times 1, and so 0 factorial is always 1. So it is mathematical definition. 0 factorial is always 1. Okay. And 1 factorial is 1. 2 factorial is 2 times 1. And 3 factorial is 6. And 4 factorial is 24, and so on. Okay. So the shape of binomial distribution is like this. So if pi is less than 0.5, then the shape of distribution is skewed right. And pi is bigger than 0.50, then the distribution shape skewed left. Pi is 0.8 or 0.9, then the distribution is skewed left. And pi is less than 50%, then distribution is skewed right. And pi is 50, then the distribution is symmetric. So here, binomial distribution is skewed right if pi is less than 0.5, and skewed left if pi is less than 0.5, and it is symmetric only pi is same as 0.5. Okay, so here it is. So it is an application. So on average, 20% of the emergency room patients at one hospital lack health insurance. They do not have health insurance. 20% of the patient does not have health insurance. So then, random variable. So in the random sample, 4 patients in the emergency room, and what is the probability that 2 will be uninsured? So we have 4 patients in the emergency room, and the probability that 2 will be uninsured. Okay. So then this probability is that, so let's define the x is the number of uninsured patients. And the probability that so one of patients has the uninsured patients is 20%, and the probability that they have insurance is 80%. So then we only have 4 patients, so the number of uninsured patients can be 0, 1, 2, 3, 4. Okay. So the mean of uninsured patient among 4 patients are n pi. So n is 4 and pi is 20%. Finally, we have 0.8 patients are, so the expected value of uninsured patients. And the standard deviation is given by sigma, and it is square root n pi times 1 minus pi, so it is 0.8 patients is the standard deviation. This 0.8 is standard deviation and 0.8 is mean. So by chance, these two numbers is the same, but it is not in general. Okay. So then the probability that the patient in the for emergency room has no uninsured patients. Probability that X is 0, number of uninsured patients is 0, is actually it is given by 0. So it is 4 factorial. Okay. Probability that X is number of uninsured patients is 0 is 4 factorial divided by 0 factorial times 4 minus 0 factorial. So this equation comes from this equation. So let's go back to the slide. So that in general, probability that X is same as X is n factorial divided by x factorial 1 minus x factorial n minus x factorial times pi to the n times 1 minus pi to the n pi to the x power and 1 minus pi n minus x power. Okay, so that is the probability that X has the value X. So here, the probability that X has value 0 is 4 factorial over 0 factorial, 4 minus 0 factorial, and pi to the X is 0, so pi to the 0 power, and 1 minus pi to the 4 minus 0 power, and we obtain this number. And probability that X is same as 1 is given by this equation, and we have this probability. Probability that the uninsured patients, number of uninsured patients is 2 is apply this equation, and we obtain this number. Okay, and so on. So then we can calculate all the probability of possible outcomes. So the uninsured patient is 0, probability that uninsured patient is 1, 2, 3, and 4. Okay, and sum of all the possible probability is, of course, should be 1. And it is probability density function of number of uninsured patients, which is following the binomial distribution. Okay. So it is 0.40696 as this number. And that is also 0.4096. And this number is this one, 0.1536, and so on. Okay. And that is the cumulative distribution function. So first one is this one, and second bar is sum of this bar times sum of these two number is in here, and this one is obtained by sum of these 3 values, and this one is obtained by the sum of these 4 values, and that is sum of all the numbers will be here. Okay, so then we know that probability that X is 0, probability that X is 1, and so on, and probability that X is n. In our example, n was 4. So then if we know all the possible probabilities, then what is the probability that x is less than or equal to 2? So probability that x is less than or equal to 2 is that probability of x is same as 0, 1, 2. So this event and this event is mutually disjoint, and this event and this event are also disjoint. So we just calculate it by sum. Okay. If they have some intersection, then the equation will be more complex. But in binomial distribution, this event and this event and this event, these three events are all totally disjoint. So we just sum them up, then we obtain this probability. Okay? So we have this probability. Okay? But when you calculate the probability that x is strictly less than 2, so then this one is probability that x is 0 plus probability that x is 1. So probability that x is 2, this probability should be excluded. So we do not calculate it. We only calculate this 2 case. So when we have this inequality. So be careful. We don't have, so x is strictly less than 2, then this number should be excluded. Okay. And probability that x is greater than 2. Okay. So then it is, so here is 0, 1, 2, 3, 4. So then probability that x is greater than or equal to 2, then so including 2, we have this probability. So then it is the same as 1 minus probability that x is less than or equal to 2, less than or equal to 1. So 1 minus probability that x is strictly less than 2. So that is this one. But probability that x is strictly less than 2 is the same as, so this one. Strictly less than 2 is the same as probability that x is less than or equal to 1. So we can say this equation. So that probability x is greater than or equal to 2 is same as 1 minus probability that x is less than or equal to 1. And then we have this result. So if you want to know this probability, then we consider this probability, and so it is 1 minus probability that x is less than 2, and it is same then as 1 minus probability that x is less than or equal to 1. And this probability can be calculated by this equation. Okay? So okay, these equations. So it is actually the probability that x is greater than or equal to 2 is 1 minus probability that x is less than or equal to 1. So it is 1 minus probability that x is exactly 1 minus probability that x is same as 0. Okay? So then we know this value. We know this value from the probability density function, and we can calculate this probability. Okay, and we can use appendix A, but so it is not important because in this case we have Excel function, so we can use the binomial distribution implemented in Excel. So when you would like to calculate the probability density function, then you can use this Excel function. So then this complex equation is not easy to calculate by hands, so you can use this Excel function for your convenience. Okay. Okay. And the last topic is Poisson distribution, but it is a little difficult for the undergraduate students in the College of Business, so I would better not. So I would better skip it. Okay. So then that's it. So it is the end of chapter 6.